Today, we are going to discuss measures of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measures of central tendency are sometimes called measures of central location. They are also classed as summary statistics. The mean, often called the average, is most likely a measure of central tendency that you are most familiar with, but there are others, such as the median and the mode. The mean, median, and mode are all valid measures of central tendency, but under different conditions. Some measures of central tendency become more appropriate to use than others. In the following sections, we will look at the mean, mode, and median, and learn how to calculate them and under what conditions they are most appropriate to use. First, the mean. The mean or average is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data, although its use is most often with continuous data. The mean is equal to the sum of all the values in the dataset divided by the number of values in the dataset. So, if we have n values in a dataset and we have values x sub 1, x sub 2, up to x sub n, the sample mean, usually denoted by x hyphen pronounced by x bar, is x bar equals x sub 1 plus x sub 2 up to x sub n. This formula is usually written in a slightly different manner using the capital letter sigma, which means sum of x bar equals sigma x sub n, or x bar equals sum of x sub n. You may have noticed that the above formula refers to the sample mean. So why have we called it a sample mean? This is because in statistics, samples and populations have very different meanings, and these differences are very important, even if, in the case of the mean, they are calculated in the same way. To acknowledge that you are calculating the population mean and not the sample mean, we use the quick lower case letter mu, denoted as mu. Mu equals sigma set x sub n, or mu equals sum of x sub n. The mean is essentially a model of your dataset. This is the value that is most common. You will notice, however, that the mean is not often one of the actual values that you have observed in your dataset. However, one of its important properties is that it minimizes error and repetition of any one value in your dataset. That is, it's the value that produces the lowest amount of error from all other values in the dataset. An important property of the mean is that it includes every value in your dataset as part of the calculation. In addition, the mean is the only measure of central tendency where the sum of the deviation of each value from the mean is always zero. Now let's go to when not to use the mean. The mean has one disadvantage. It's particularly susceptible to the influence of outliers. These are values that are unusual compared to the rest of the dataset by being specifically small or large in numerical value. Another time, when we usually prefer the median of the mean or mode, is when your data is skewed, that is, the frequency distribution of your data is skewed. If you consider the normal distribution, as this is the most frequently assessed in statistics, when the data is perfectly normal, the mean, median, and mode are identical. Moreover, they all represent the most typical value in the dataset. However, as the data becomes skewed, the mean loses its ability to provide the best central equation for the data because the skewed data is dragging it away from the typical value. However, The median best retains this position and is not strongly influenced by the skewed values. This is explained in more detail in the skewed distribution section later in this guide. The median is the middle score for the set of data that has been arranged in order of magnitude. The median is less affected by outliers and skewed data. In order to calculate the median, suppose we have the data below: 65, 55, 89, 56, 35, 14, 56, 55, 87, 45, and 92. We first need to arrange the data in order of magnitude, smallest first: 14, 35, 45, 55, 55, 56, 56, 55, 87, 89, and 92. In our region mark is middle mark, in this case 56, which is highlighted in bold, is the middle mark because there are 5 scores before it and 5 scores after it. This works fine when you have a odd number of scores. But what happens if you have an even number of scores? What if you had only 10 scores? Well, you simply have to take the middle two scores and average the result. So, if you look at the examples below: 65, 55, 89, 56, 35, 14, 56, 55, 87, and 45, we again rearrange the data in order of magnitude. So we have 14, 35, 45, 55, 55, 56, 56, 65, 87, 89. Only now we have to take fifth and sixth score in our data and average them to get a median of 55.55. Lastly, the mode. The mode is the most frequent score in our dataset. On a histogram, it represents the highest bar, a bar, in a bar chart or histogram. You can, therefore, sometimes consider the mode as being the most popular object. Normally, the mode is used for categorical data when we wish to know which is the most common category: skewed distribution in the mean and the median. We often test whether our data is normally distributed because this is the most common assumption underlying a statistical test. When you have a normally distributed sample, you can legitimately use both the mean or the median as your measure of central tendency. In fact, in any symmetrical distribution, the mean, median, and mode are equal. However, in this situation, the mean is widely preferred as the best measure of central tendency because it is the measure that includes all the values in the dataset for its calculation, and any change in any of the scores will affect the value of the mean. This is not the case with data with median or mode. We find that the mean is being dragged into the net of the skew. In this situation, the median is generally considered to be the best representative of the central location of the data. The more skewed the distribution, the greater the difference between the median and mean. The greater emphasis should be placed on using the median as opposed to the mean. A classic example of the above right skewed distribution is income. Salary for high earners provide a false representation of the typical income if expressed as a mean and not a median. If dealing with a normal distribution, and test of normality shows that the data is not normal, it is customary to use the median instead of the mean. However, this is a more rule of thumb than a strict guideline. Sometimes, researchers wish to report the mean of a skewed distribution if the median and mean are appreciably different, and if it allows easier comparisons to prove previous research to be made. Now, we go to the summary of when to use the median and mean, median, and mode. Please use the following summary table to know when the best measure of central tendency is with respect to different type of variables. Type of variables. When it comes to nominal, the best measure of central tendency is mode. In ordinal, the best measure of tendency is median. And when it comes to interval ratio, or ratio while not skewed. The best measure of central tendency to use is mean, but when it is in interval or ratio but skewed, the best used measure of central tendency is median. These ends are done.